So here's a few domain and range examples. If you recall, domain is the set of all the x's. Range is the set of all the y's or function values. And depending on the transformation, it will affect the range or domain that's given. So for this first example, these are pulled from your textbook. We have a range for a function that goes from -2 to 12, and it wants to know what would be the range of the function negative q of x. Well, if you recall, a negative on the function creates a reflection over the x-axis. So the function values actually do change. So again, we don't know what the function looks like, but we know that it's going from -2 up to 12, and that is where the function lives. Okay, this a little bit. That's where the current function lives, regardless of what it looks like. It only goes from -2 to +12. So if we reflect that over the x-axis, instead of coming up here to +12, it's now going to come down to -12. And instead of starting here at -2, it's going to only come up here to +2. It just literally takes that value and reflects it up across the x-axis. Takes the 12 value, reflects it down. So instead of going from -2 to 12, it's now going to have a range that goes from -12 to 2 if you negate the actual function. So the range value here would go from -12 up to +2. Very similar for the next few ones. We have a function that has the domain of t greater than 0 and a range that runs from -4 to 7. So it wants to find the domain and range for each of these transformations. So for this first one, we have a negative on the inside of the t. That's a reflection over the y-axis. And if you recall, it's a change on x values. So it's not really going to change the range. The range is still going to run from -4 to 7, but the domain will change. And how the domain will change, it's going to reflect over the y-axis. So if you could imagine a graph where the domain was everything greater than 0, and you reflected that across the y-axis, now your domain is going to be every t value that's now less than 0. And it still won't include 0 because it was a straight reflection over and it didn't include it to begin with, so it won't include it when it goes below 0 either. All right, for number 6, for this example, if we negate the function, it's much like the one from above. It's going to be a reflection over the x-axis, and it's only going to be a change on the y values. And all that's going to affect is the range. The domain will remain all the t values greater than 0, but the range will sort of flip. So instead of going, again, if you could imagine the graph, it goes from -4 up to +7, and now those are going to reflect over the x-axis. So it'll actually come down to -7 and then go up to +4. So the range will be from -7 up to 4. And that negation is on the function itself. For number 7, if we do both, the negation and reflected over the x and the y, it'll combine numbers 5 and 6. So the domain will be all t values less than 0, and the range will be in between -7 and 4. Again, you want to write it with inequality or brackets, it doesn't really matter. For number 8, we'll do a negation on the function, so that'll reflect across the x-axis, changing our our range values. Again, here's your x-axis. If you reflect over that x-axis, you're changing range values. And this t minus 4 actually shifts to the right 4. So for domain, again, if you could imagine a graph where your graph existed everything greater than 0. If you took that graph and moved it to the right 4, now everything will exist greater than 4. So the domain will be all t values greater than 4, and the range will again take those range values to begin with because we negated the function and flipped them from -7 to 4. Right. And those are pulled from section 1 and 2, I believe. And the next one, because it's on the inside, is going to pull it from section 3, where you have your horizontal compressions and stretches. So for this first one, the bottom example, we have a domain that runs from -12 to 12 and a range that runs from 0 to 3. So if we do the function L of 2x, again, the 2 on the inside is going to be a horizontal compression by a factor of 1/2. So because we're horizontally compressing things, it affects x values by that factor of 1/2. So the range won't change. The range will still run from 0 to 3. But the domain will get compressed by a factor of 1/2. Again, it says 2x on the function, but because it's inside, we'll do the opposite, do the 1 over, do the reciprocal, and instead of going from -12 to 12, we'll half both of those, and our domain will now run from -6 to 6. And for part B, we now have a 1/2 multiplied on the x, so this time it's a horizontal stretch, but in order to stretch it out, we'll have to do by a factor of 2. And again, because we're horizontally stretching things, it's only going to affect x values by that factor of 2. So the range, again, will remain in between 0 and 3, including those values. But the domain is going to get, again, we're stretching apart left to right. We're still going between 0 and 3 on the range, but the domain is going to get stretched out. And this time it's going to be a factor of 2. So we'll take those -12 to 12 and we'll double them. And now our domain will run from -24 to +24. So you have to, for domain and range, watch if it affects the x value, then you'll change domain. And if there's a transformation on the function itself, it will change the range.